Hello all, welcome to the course on object-oriented programming using C++. Today's topic of discussion is function templates. Myself, Abhinay Gulabrao Damankar from IT Department, PICT, Pune. Today we are going to see how the function templates are used in C++. Okay, let's next. In today's topic, following contents to be covered. What are the function templates? Which classes can be used for function templates? And some example. Actually, function templates, we have two separate videos. This is the part 1 video, and in this part, we are going to see this content to be covered. Function templates, which classes can be used, and some examples. Moving ahead. Before we proceed to the function templates, student should know the following concept very properly, very thoroughly. I hope you all know this concept very well. That is how to use the functions. Means how the functions are used and how the call is to be given for the functions, even if the method or instances of a class, right? How to invoke it using object, that should know it. Everybody must know it. How function works, right? Return type, function name, arguments, right? And even if the very important thing, the parameters that called, it is actual parameters, formal parameters, this concept everybody in the C++ must know. How to use primitive data types and its working. Primitive data types means our inbuilt data types, that is integers, floats, character, double, these kind of data types. And how it works, that also should know before we should proceed these functions. And very important, concept of pointers and concept of references. Yes, references are a little bit different than the pointers, and references are introduced in only C++. So before beginning with this topic ahead, everybody must know this or should know this concept to proceed. Then only function templates will be the very easiest task to understand. In today's discussion, I will be taking some concept and immediately I will be taking the example, right? Then are you ready? Yes, then we should start it. Moving to the next slide. Function overloaded. I hope this keyword overloaded, everybody must know it. The name itself is a self-explanatory. When C++ people are studying, right, are studying C++. So overloaded is introduces in C++ only, right? So let's say, suppose if we need to find absolute value of an integer. This is the example we have taken first, an example, and then we will take a generalized thing. If we need to find absolute value of an integer, double, float value of a number, then what we need a set of function to return absolute value of a number. Then what will be the solution? The solution is write a overloaded function, and you probably or all probably will write these kind of functions, right? Integer, myApps, parameter of integer type. Second function he will write or she will write myApps. The function name will be the same. As we already said, overloaded functions. Right? We need to find out the absolute value of integer, float, double, right, on different data types. This is the now second one, double. Okay, it will be written double. My app, the same name, double. It takes the argument of type X of type double. And third type, we will overloaded same name, function name, which takes float value and will return float value again. So we have to write, there is three different ways, right? Three different functions, three different overloaded function, I will say this. Now one can think that how many variants should we have to write, right? So can we have such facility that can we able to write a generalized function instead of writing three different things? Okay, can we say that it is generic function or generalized function which takes same name, my apps, and some data type as an input and will return the same type as a return value, right? So can we take such kind of arrangement in C++? Yes, it is possible using function templates, right? Going to the next. Look at this function. Let me clear these things. This is a function template. So this kind of problem can be solved using function templates. Okay, now don't get confused with these terms and how it is written. These things I will be explaining here. This is a very simple swap statement, very simple swap function. Let's say this is swap which return void, which take first argument temp1, second argument temp2 of some type T, some data type T reference. Okay, and T will be available, we will be declaring over here, right? So how we have to write this function templates, right? This is the normal function. This is the normal function body. And here we have defined one type. Temporary is a variable of type T. All right. So this type T will be replaced at the runtime. Okay. So this is a reference variable, as you know that. Okay. So we already told that the references, how to take a references is very important. So this is the reference variable. This is also reference variable. And then in this normal swap logic is implemented. Okay, right, and return the things, right? So this is the example of swap function. In this way, we can write. So template function, if you any generalized function, any normal function can be converted to the template function. How we can convert it? Write it down that function along this line. For example, swap arguments, their reference argument or their pointer arguments or maybe normal arguments with the data types. Okay, now this is the data types, right? This is the data types. So instead of data types, replace that type with some type name and insert one line ahead with the swap. Means prefix it. Okay, इसके सामने ऊपर में लिखना है, ऊपर में, or we can see that prefix it. Template is a keyword, right? It is a keyword. So introduce keyword. This is angle bracket. This is angle bracket. We can say placeholder. Okay, this is called placeholder. And this is the data type T to be defined. This is the keyword again. This is the keyword again, and this is the data type need to be converted at a runtime. And the same type is if you are having only one data types, then replace that type at runtime. Got it now? So let's move ahead with the next slide. Let's say, for example, here we have my swap, right? The same thing. So same thing is written here. OK, and here we have three different data types. First, integer value. Second is double. Third is character. And even if pointers can be swapped it. OK, pointer can be swapped it. So after swap, we can have these kind of things. OK, right? So let's say this is the generic function we have written, which text, which replace, if we given the call here, OK, then my swap. So this is the call, we can say this is the call. This is the call, and this time my swap value, it will take X and Y. It will take X and Y. Then X and Y, the type of X and Y is integer. And T will be taken integer type value, right, at this moment of time. Then second swap, that is P and Q, will be of double type. And third case, my swap S and T will be taken as a character type. OK, so character type, it will be swapped. OK, right? So character value will be swapped with the ASCII values will be swapped at that moment of time. So shall we, are you ready to test this code? Yes, we can test this code. OK, right? Let's go ahead with the testing the code. Look at this program. This program we have written here the template function of same type. We have written here integer value. We have declared double value. We declared character value S and T. And this is the call I have given here for X and Y for my swap. Intentionally, I have taken here my swap because swap is a already ready-made function available in C++. So that's why I need to adjust the call, the function name my swap. So here we have given Q and P my swap and here S and T my swap. OK, right? Now let's compile this. OK, zero error, zero warning, and then let's run this. OK, now observe here very well. Observe where here some integer value gets swapped. Before integer value, what is the value of X and Y? X and Y are 10, 20, and after that the same function will be swapping. Now here observe the value of 10, 12.34, and this is the double get swap, right? And here we can say character get swapped, okay, in this way, right? Character gets a swap. So in this way we can see here, okay, the first testing. Got it now, right? Okay, moving ahead. Let's close this. The same function, the same templates can be used for the same code can be used for 3 different call, right? Exactly. Moving ahead. Let's take another example, function templates, okay, of returning the minimum value, returning the minimum value. Okay, here we have defined min1 function. Min1 function takes argument A, argument B of reference type, of constant reference type T. T is defined here. Okay, all right. And this is the conditional operator that you know that when this condition is true, A will be returned, or if condition is false, then B will be returned. Now I think you guys you known these things already. I assume that you know these things already. Okay, now consider that this is another example that any value, whether it is a double, whether it is float, whether it is character will be checking this value. Their ASCII value will be checking for minimizing min1 function. Okay, moving ahead. Now let's take this code. Okay, we have written here min1 function, and this is the call for min1 for 2, 3. Min1 2, 3, and whatever the minimum value is there is going to be initialized to A, and A will be displayed. Rightwise here the same function will be utilized for 4.5 and 2.3, that is a double, or we can say float value. Okay, this is integer value and this is a float value. The same function can be utilized for to returning this the same minimum value. Okay, right? So let's test this code. So let's test this code for our understanding. Okay, now this is the code that we have written here. Function template class T minimum constant min1 function is take A, B and return A minus B, A less than B, and based on conditional operator that will be returning. I will be taken here 6, 8 and 4 and 5 to for different purpose. Okay, let's compile this. 0 error, 0 warning. Then let's run this. Now observe here. Okay, observe here. We have means let's say here. If you observe this, here we observe this minimum between 6 and 8. So 6 is returning here, right? And here 4.5 and minimum 2.3. So definitely 2.3 is minimum and 2.3 will be getting here, right? Exactly 2.3 is getting here. So this code is perfectly working in this condition, right? So next, moving to the next part. Let me clear the screen. Even if third function can be returned, like for example, absolute value. For example, absolute value, if you find what is absolute value, suppose Suppose minus 10 is there, then what is the absolute value will be plus 10. Okay, it means, and when we will say 15 plus 15, then their absolute value is always 15, right? So if the value is less than 0, if the value is less than 0, then definitely we have to do this task, right? So absolute value. So if a is less than 0, okay, this is the class, this is the function template class t is some type, same definitely type, and we have taken one reference variable of that type here, that type, okay, and my apps, and will be returning of the same type, okay, a reference to the same type. Okay, please, I will suggest you, please see what is meant by referencing concept. Please try to clear that concept very well. Okay, then only what is meant by referencing is okay. Now, for referencing variable, what is implement? What is this? This is the things int star a. Uh, Only for your purpose, information purpose. These things are different. Okay, these things are. This is the pointer variable creation. A is a pointer to integer type. I will, how we can say, how we, I will read it out like this way. A is a pointer to type of integer. A is a reference to the integer type container. Okay, integer type data type. A is a reference. Okay, so reference means, suppose this is the value a and this is the location a. This is the location a in the memory, and we can say in the memory and value is 10. So we have taken n number of references to the this is the same location. Okay, same location. So reference means taking aliases. Okay, aliases. Uh, this is very very well known that the same location having the name A as well as the name B as well as name C, and suppose somebody is creating B++, for example B++, so definitely A is also update to 11. Okay, and also C is also update to 11 automatically. So that is called a reference variable. This is called a reference variable. References, and this is pointer variables. Okay, so what is meant by pointer variable? I will be dictating here very shortly. Suppose this is the 10. Okay, this is the content 10. This is the location A, and one pointer P is initializes. Okay, and somebody we can initialize a Q pointer here also, R pointer also with the same location, no problem. And suppose somebody is doing Q++. Okay, now what is meant by pointer? Pointer means they are they are no, they are save the memory location. Okay, memory location, ये इसका location होगा 1001. Okay, so Q stored 1001. Okay, so Q will not store 10 value, and somebody, so for example, if you want to access Q plus Q star, then only we will get the 10 value. Okay, and somebody is saying that Q plus plus, then definitely the next address will be updated to 2. Okay, not 11, right? P Q R will not be 11. This is the difference between pointers and references. Hope you understood. Please refer any book for references. Okay, right? References are introduced in only C++. Moving ahead, function templates and user-defined class. This is very important now. The things are going to be complex now and little bit very interesting. Okay, function templates and user-defined type. Now, please tell me what is my user-defined type? User-defined types means there are some kind of structures. They're kind of classes is defined, right? Classes can hold user defined types, right? That is called user defined types and classes or classes. right? What will happen if such kind of things are introduced into the function templates? Function template and user defined types. All operators. Now the things will be complex here, means need it to very carefully to be handled. If the same function encountered when it will be working on the user defined types, means object. Okay, means on objects. Objects are the instance of a classes, and class is means user defined type, जिसमें हम different floating type, integer type group करते हैं और उसको उसका एक reference और एक instance create करते हैं, that is called object. And if something minimum between the object हमको निकालना है तो the same things cannot be work out. Okay, so what will be happen? All operators used in function templates must be supported in the user defined type, that is classes. In other words, all necessary operators, okay, this taken care, we should must be taken care of this. In other words, all necessary operators must have been overloaded in the classes. Okay, we will cover this in the next slides. In addition to this, the necessary constructor of must be available for creating temporary variables, temporary object whenever necessary. Next, for example, okay, for example, let's consider the same example here. Min1 function. We have template now. Here A and B are not a primitive data types. A and B are objects. Okay, A and B are objects, not a integer, float or character. ये अभी character float ये नहीं रहे, objects बन गए, objects इसको treatment दिया, right? The same things can be written here. Template class T, reference type of object, min1 function, then reference object reference of that class T here reference, and minimum between these two, the same function. Now A and B are two objects, not a primitive data types. This code only works when, okay, only works when it assumes that operator less than is defined in the class T. Okay, इसका मैं थोड़ा आपको clear cut idea देता हूँ. See what is object? This is obj object, and this is also object. And less than operator on the objects will not directly will not be done this task. So function operator overloading एक concept है, operator overloading का concept है. operator function आपको लिखना पड़ेगा less than करके. Okay, which will take objects as a input, object as a two objects as a input. Okay, आपने operator overloading पढ़ा होगा. Okay, right? Using friend function, using member function, right? So तो ये वो concept है, ये operator आपको overload करना पड़ेगा. Okay. In other words, to say the less than operator must be overloaded, see here, to perform the above task on object of class. Okay, so the same function cannot be utilized on objects. ओके, ये प्रिमिटिव डेटा टाइप्स अगर रहते हैं ए एंड बी, इंटीजर, फ्लोट, कैरेक्टर, तो ये सिंपल चल जाता, लेकिन ए एंड बी इज नॉट अ प्रिमिटिव डेटा टाइप्स, नाउ ऑब्जेक्ट्स बन गए. ओके, नाउ लेट्स सी, अगर हम सेम कोड रखते हैं तो व्हाट विल बी द effect. Okay, so let's say we will test this code, bad coding. Okay, bad code मतलब ये नहीं चलेगा क्योंकि we must have to overload the operator. Look out this code. This is the template. function as written as it is. This is the one class, fraction class. Okay, this is the fraction class where we have number, numerator, denominator, and in private stuff, okay, in public stuff, we have what is this constructor function, right? And this is parameterized constructor and with default parameter 0, 0, right? And this is initialized with num and denominator, right? Okay, so the these are the fraction class. Let's create object. Let's create object over here. Okay, let's create object over here. P is an object. P is an object. Okay, which takes 2, 3. P is object 2, 3. Okay, num value is initialized to 2. Denominator den value is initialized to 3 automatically. Let's second object Q. So now P become one object with having 2, 3 and Q becomes 4, 5. Right? We have another R objects over here. We were defined like this way, and which will be saying that minimum one function will be invoked, and इसमें से कौन सा छोटा है हम वो देखेंगे, right? Min 1 and min 2. कौन से objects हो? Now P and Q are not a primitive data types. It is a type of objects, dear students. It is now it is object, and for object this function will not be work out. Okay, the simple. Now what happened here after giving this call? Okay, the data type will be matches over here. T will be replaced with the object of that type, and then this operator will not be resolved. Okay, let's say what compiler what says. Okay, let's compile this code. So let's compile this code. What it says that observe now here, observe very well here. This is no match found. Observe this line, no match found for the operator. No match found for the operator less than means you must have to overload or to tell compiler ki what operator less than is doing. Okay, and write their code over there clearly, right? So these things is need to be done, and let's say we have solved this by using good code. Okay, now here we have rectified our code, and here we have now return one friend function which overloaded operator function. Okay, which says operator less than, which takes a reference type of fraction class, another reference fraction class, and here we have implemented these operator functions. Okay, right, and then it will return 1 or 0 to this function. This is the function call. Hope you understood. A less than B is a function call to the objects, right? So इसे function call कहते हैं. Okay, A less than B because A is object है और B भी object है. तो ये क्या करता है? इसको invoke करता है नीचे वाले function को, right? नीचे वाले फंक्शन को इन्वोक करता है, and that why this will be this operator function will be invoked, and based on that return 1, return 0 will be there, and then A and B will be selected. In turn it will be returning to this. Okay, this code is as it is, and r dot display, we have immediately displayed that things. Okay, display number. Let's see, let's run this code. Hope you understood this code. Now let's compile this. We definitely have 0 error and 0 warnings here, and then run this code. Fantastic. Excellent. Template function visited and checking for the object is small. So see here. So see here, I intentionally see here intentionally template function. See your call immediately when you are here. The compiler will give the call to this function, and this code, this line will be executed. After that, this is another call, and the call given to the this operator function, and here overloaded operator function came into picture. I have just see out this statement to verify this one, and then r dot display will be done, and then this function will be returned. Look out this. I will again compile and run for you. Fine. Okay, see here, template function is visited and checking for the object which is small. So this is small, and after immediately that overloaded function, overloaded operator less than function, overloaded operator function. So just for our side, I have mentioned here. Okay, and this is the r dot. This is the display. Right, this is the good code, and operator overloaded function must be written for that when we are dealing with, when we are definitely dealing with objects. Moving ahead, in the same way we have to talk with the rest of the swap function also. Okay, now look out this swap function. Look out this swap function. Now suppose we want to swap two objects content. Okay, two objects, then this will not be the normal, this will not be the normal functions. Okay, this will be normal operations. So let's say t temp1 temp2 of the object reference of t. This is also one of the temp reference of t type class. So here one constructor must be invoked to initialize this thing. Now, what is the constructor? Hope you understood at the first lecture itself. When objects are created, when objects are created at the same time that is going to be initialized the default value. Okay, so here object creation is going on, right? Object creation is going on, so definitely no argument constructor must be invoked. In the same way, now here let's say assignment operator. Okay, this is the assignment. Object 1 content is going to be initialized to object 2 content, whatever may be the same things. Okay, so here assignment overloaded operator must be invoked. Okay, operator assignment must be overloaded. Are we getting this? What I'm to say that? So that's the very important things that when we're dealing with the objects of such type, so nor constructor assignment overloaded operator must be overloaded here. Okay, this swap function will take working on the object instead of primitive type. The class T has must have default constructor and or no arg constructor, default constructor or no arg constructor. Now right now this is no argument constructor. We are not sending any value. Otherwise it will not be compiled. Okay. Now moving ahead to the next slide. Okay. Right. Let's say absolute value. let's say function absolute value. Now observe this function. Now a is a object and 0 is a normal integer value. Okay, normal integer values. Now here we are comparing this kind of thing less than operator with the numerical value, object versus numerical. तो यहाँ पे कौन सा हो गया, object versus numerical आ रहा है. Okay, comparison में, right? So definitely a is object type and here 0 is a normal integer value. So here one issue must be resolved कि view how to convert 0 to type T. See what happened, everybody says that कि comparison में दोनों साइड सेम टाइप की होनी चाहिए, right? A लेस देन बी होना चाहिए, मतलब मीन्स बी एंड ए ऑफ द सेम टाइप while comparing, less than equal to, while any comparing we must require the same time. Okay, right? So that's why it is says that, तो यहाँ पे ये ऑब्जेक्ट हो गया राउट एंड दिस इज द numerical value. So that's why we need to convert 0 to type T. Now for this in C++ we have these things to be learned. Okay, this is to be learned. ये एक section है, class T has a constructor to convert 0, okay, to type T, the integer to class type. And for refer, okay, that's why I have given here the refer 3 types of type conversion. Class to primitive type. Okay, class type to primitive type means integer, float and character जो भी है, जो primitive types हमारे integer predefined types है, user defined type to primitive type. First, primitive types to class type, second type and class to class type. How to convert this, इसके लिए completely एक section है C++ में. Please go ahead, without which you cannot do such kind of thing in function overloading. Okay, ये दिखने को तो बहुत सिंपल दिखता है, लेकिन अगर ये a primitive type नहीं रहा, ये object अगर invoke हो गया object, तो ये तो primitive 0 है, तो ये compare नहीं कर पाएगा. And again less than operator overload must be overloaded. Again observe this one, a is a now object and negative of any object must invoke unary operator overloading. Unary operator overloading. So that is a very important thing that you everybody must should know this. Okay, must know this, that operator minus less than must be overloaded in class type T. Unary negation operator must be overloaded in type T here. Thank you for the part 1 section. Next part we will discuss in depth little bit different issues. Keep watching that. Thank you.